No other aspect of sailing offshore has more impact on the boat and crew than the weather. While we can't control the weather, the more we can understand about it and the forecast that lies ahead, the better our chances of a safe and successful passage. For the Storm Trysail Foundation, I'm Gary Jobson. Noted safety and seamanship expert Ralph Naranjo, and author of The Art of Seamanship, spent time with us talking about how we can better use weather information to our advantage. Explain to me why the Gulf Stream even exists.
The Gulf Stream stems from the equatorial current. You have strong easterly winds blowing across the Atlantic just above the equator on the northern side. That water that is driven all the way from Africa eventually has to find its way up the coast. It splits into the Florida current, and that Florida current starts coming up the coast, the east coast of the U.S. The deep ocean trench or abyssal plain shoals as you get near the continental shelf. The stream follows that profile, and the northern wall of the stream is right up against the continental shelf, and the deep water accepts the pathway or sets up the pathway, and the stream makes its way northward.
Does the stream extend all the way down to the ocean floor, or is it more surface?
It's surface. It varies in depth, but it's a surface current. And what that current does is it not alone makes its way up the East Coast, it makes its way all across the Atlantic. I was surprised a year ago in Norway to find I was wearing shorts in the Lofoten Islands in Norway, where Gulf Stream waters actually keep things temperate during the summertime.
How does the fast-moving Gulf Stream currents affect the weather?
It's like Gulf Stream current adds heat to the equation. In essence, what you're doing is you're boiling a pot of water. You take a thunderstorm that's developed over land and it's moving across into the Atlantic. When it reaches the Gulf Stream, the north wall of the Gulf Stream, it literally erupts. The cloud tops get higher, the vertical instability grows, the amount of energy, convective energy, builds up, and what you end up with is more severe thunderstorms, stronger winds, and microbursts that are much more frequent than they would have been had the Gulf Stream not been there.
So how does the sailor in a relatively small boat prepare for these somewhat violent thunderstorms around the Gulf Stream?
First thing is you expect them, and they tend to build up in the late afternoon into the early evening. By later at night, they calm down a bit. It has a lot to do with sun heating as well as the warm water, as well as what's come off the coastline. So the sailor, to be prepared, recognizes that they're going to happen. You need to be ready to reef in a hurry, shorten sail. You're going to find some thunderstorms in the stream, but looking at Ocean Prediction Center website information gives you a heads up on when they're much more likely. They're really likely when a cold front's passing through, or when there's a low pressure system or a trough in the area. That's when the Gulf Stream thunderstorms are really more violent and more prolific.
How windy can they get?
Did an 82 Bermuda race. Rod Stevens was the watch captain. I was the other watch captain. Rod said, here's the way we're going to sail puffin through the stream. We're not going to reef the main. We're going to ease off, flatten everything, and we'll feather it, and we'll beam reach through these squalls. We saw squalls that were probably 45, 50 knots of wind. And as long as we spill the breeze, flat mainsail, we drove through. Heavy vessel, a lot of riding moment, she was able to contend with it. More modern boat, lighter with less riding moment, more need for crew ballast. You need to contend differently. You need to reef a little earlier and be ready to tuck it in and shake it out.
I'm a big believer in feathering, by the way. Just feather 2-3 feet of that jib and baby it.
Right.
Lead aft, feather it.
Yep.
It has served me well.
Yep.
Not flogging, just feathering.
Nope.
Warm and cold eddies are spawned from meanders in the Gulf Stream and become independent rings of warm or cold water. 10 to 15 of these warm and cold eddies are generated annually. The warm eddies rotate in a clockwise direction, while cold eddies spin counterclockwise, and most are eventually reabsorbed by the stream. The set and drift of the current circulating around these eddies can be harnessed and affords a significant tactical advantage to stream crossers and those headed to Bermuda.
Warm and cold eddies are tactical advantages, But there are also safety issues in that if you take the wrong tack and you go through opposing the current in an eddy, you're going to be in the stream longer. If you're trying to put the stream to best advantage, if you're getting a lift from it, stay in it. But if you're getting headed, get out of it as quickly as you can. Sometimes the stream is overplayed in a tactical point of view, in that you're not looking at the wind and the speed, boat speed that you're able to make. So my belief is take advantage of what is going to get you through the stream most quickly and avoid the negative side of the eddies, meaning when you're getting headed by the current, taking the long leg to find favorable eddies may pay off, but there is no guarantee.
Describe for me the difference between a warm eddy and a cold eddy.
Warm eddies form on the inside of the stream. They're pinched off circulations that carry warm water into the colder current that comes down from Labrador. It's a Labrador current, so you have these warm gyres. The circulations around warm eddies and cold eddies are just the opposite. So what you're trying to do is put that current circulation in your favor, using it as a lift in the direction you're going. I think that a good Gulf Stream forecast prior to departure is a handy thing. It won't get old in a hurry. Contrary to a weather forecast, a 3-day-old weather forecast is old and out of the picture. A 2-week-old Gulf Stream forecast is still, much of it is in play, after 2 weeks.
So if you have a deep low off Hatteras, what do? Coming up the coast, you're out there away, and you look at the grib. What do you do?
Deep lows off Hatteras are one of the biggest concerns that an East Coast sailor has, especially, for example, if you're coming back from the Caribbean in the fairly early springtime weather systems. Those lows have a tight isobar pressure gradient. You'll see lows down around 970 millibars in the early springtime that develop off Hatteras and then deepen as they move northeastward. What you do is make a decision as to tuck into Charleston. Wait it out there. That's one good move if you're doing a delivery. Another is not to get yourself caught between that low and New England, because it's going to make its way northeastward in a hurry. And if you're in its sights, especially in early May, even early June, you can find some significant gale force, storm force, and it's not unheard of to see in early May still a hurricane force wind strength in some of these what are termed bombs, deep lows that originate off Cape Hatteras.
Most low pressure systems form on the polar front, a region where cold and warm air masses meet. As the system develops, the pressure drops, and warm fronts and cold fronts become dynamic features of these extratropical lows. The wind blows in a counterclockwise direction around a low at about a 15-degree inward pointing angle to the isobars. Wind speed increases as the pressure gradient steepens. The most volatile weather usually occurs near the center of the low and along the cold front boundary.
There's no shame in heading for shore if it's dangerous. When do you make that decision? What do you know that's coming that you say, if we can get to Charleston or we can get into the bay, when do we do that?
You need to, getting to shore is a key decision point, and the idea of bailing out from a plan, there's no shame in that. It's absolutely prudent seamanship. The problem is waiting too long, because on many coastlines you have harbors and jetties with bars, and they close out. You start heading for safe shelter in some areas on the Pacific coast and even here on the East Coast, and it gets pretty hairy. Manasquan works all right on the East Coast, so does Sandy Hook headed into Atlantic Highlands, but really Atlantic City is the only all-weather yacht entrance that you have along that Jersey shoreline when it's blowing 40 out of the east. So the deal is get in early if you're doing that. Coming up around Hatteras is the really tough nut. The Whitbread race that came up here, or I guess at the time it was a Volvo race, they had a tough time getting around Hatteras. The leg from Florida was tougher than what they found south going around Cape Horn. More damage, more problems. If you don't have to stay at sea, duck in early, go to Charleston, spend a couple of days, let that low get by Hatteras, then make your way north. This is especially true in the early spring or late fall.
East-southeast winds veer and increase as the vessel approaches the warm sector. The cold front will arrive with an abrupt southwest to northwest wind shift. Already in the warm sector, southwest winds will continue to build and thunderstorms are likely as the cold front approaches. Clearing skies and strong northwest winds herald the departure of the low and the approach of a high-pressure system. Facing the worst part of this weather system, this crew can expect strong east-northeast winds as the center of the low approaches and eventually passes almost directly over their position.
So, what is a GRIB file?
GRIB files are an important part of the weather forecasting process. They're called a gridded binary file, and they're basically the way meteorologists share information. It sends a lot of data, quite compressed, and it was initially, quote, in the trade, used between meteorologists. What's happened is GRIBs now are displayed on good graphics. They can be transferred easily, and what you can see is wind direction, wind barbs, pressure grids. You can see isobars. Most GRIB files come from computer-generated forecasts. In other words, there's been no human forecaster involved, and that's a bit of caution. We need to be aware that when the forecaster looks at a GRIB file, he says, gee, or she says, this particular GRIB is good under such and such conditions. The GFS model, a very functional, good US model, is best under certain conditions. And a good meteorologist knows how to make a forecast using GRIB data that's most appropriate. We saw GRIBs go astray during Joaquin. This past year's hurricane sent us all over the place in determination of where it was actually going. As it turned out, the European model was most accurate, and I'm sure there'll be lots of thoughts this year about how to take advantage of the data that is used in the European model. GRIB data is easily received with many weather system recording devices. Multifunction displays can display GRIBs, and all of the major equipment manufacturers provide GRIB readers in their display mechanisms.
One of the things you learn at the Maritime College as a navigator is you use every source that's available to you. And I know in the Volvo race and these ocean races, you take multiple weather forecasts and kind of lay them over each other, and then eventually you make a call. I mean, Stan Honey's brilliant at making the call of what to do.
Yep.
So for most sailors, you know, you're out there, how many weather sources do you like to use? And then how do you overlay them and then finally make the decision? So we'll just go one at a time. So how many weather sources do you like to use?
Multiple sourcing weather information is crucial. The first thing I do is I listen to the simple VHF forecast. It tells you local area, what's going on, whether there's a watch or a warning, whether thunderstorms are in the area, and it gives you the what's around you picture. Next thing I like to do is I prefer the National Weather Service products, 3 specific groupings: the Ocean Prediction Center, the National Hurricane Center, and the Storm Prediction Center. Those 3 opportunities to get weather information really round out the picture.
The Ocean Prediction Center provides web-based forecasts. These include both GFS model GRIB files and meteorologist-prepared 24, 48, and 96-hour forecasts. The United States Coast Guard broadcasts Ocean Prediction Center weather faxes and voice forecasts on regularly scheduled HF radio frequencies.
The Ocean Prediction Center gives us an analysis, which is the actual weather at the given time. Then they also provide forecast data, which is information about weather 24, 48, or 96 hours out. They're graphically displayed. You get to see what lies ahead as well as what's occurring at the moment. Being the skeptic I am, I enjoy then going to the National Buoy Center information to see exactly what's winds blowing at Thomas Point or perhaps off Cape Hatteras or anywhere along the coastline. You get real-time information about wind speed, barometric pressure, sea surface temperature, and perhaps wave height at many of the stations. That and Doppler radar give you a chance to ground truth those forecasters. In other words, you now can have information about what's going to happen, as well as see a snapshot with the buoy data and the radar information, that Doppler information comes out. Incidentally, you get that on the Storm Prediction Center website. So if you have the smartphone technology and you're inshore, all that's at your fingertips.
So how do you overlay all this information?
Okay. The compare and contrast process starts out with getting to understand what information is accurate most of the time. For example, when I'm not sailing, I like to windsurf, and that is a big deal between 10 knots difference in wind velocity. So what you're looking for is you're looking for wind information that gives you good wind velocity, wind direction data. Same thing with going around the buoys. It's a crucial issue to have accurate data with regard to speed as well as direction. Oscillations are going to occur. We expect that to happen. But the idea of whether the weather is being influenced by an approaching cold front or a low pressure system, some information's better than others. For example, I like what the National Weather Service does with their near-term 24-hour forecast. It's pretty darn reliable. I take the long-range 96-hour forecast and I look at it with curiosity, but I don't count on that being the weather 4 days from now. I like very much the GFS GRIB files, the ensemble information that comes out. That data from the GFS model, that's a US model, is very accurate wind direction speed-wise for the northeastern area that I spend a lot of time recently sailing in. So I like GFS model data, and I can receive that on a variety of from a variety of different sources, including the National Weather Service.
So you have your favorites.
Mm-hmm.
You've kind of looked at this in short term, long term, but you got to make a call.
Mm-hmm.
You know, are we going to stay high? We're going to go low? We're going to
Mm-hmm.
foot off here? Are we going to go inshore? How do you finally make the call? When do you use your own intuition, your own gut feeling versus all this data that you've just analyzed?
The data gives you a future picture. What you're looking for is a déjà vu feeling about the data as you move into it. So as long as the model information and my forecasts are playing out, I'm a happy person. But once I start seeing anomalies arise, meaning I'm seeing way more wind or way less wind than what I'm supposed to be seeing, I start looking for new data, a more current forecast. At some points, you need to make decisions about, gee, the gale force condition is really turning into a storm force condition. Storm's a whole new story. That's survival. The gale you can compete in, you're able to do a variety of things, but you're not going to be able to keep pressing when conditions are worsening beyond what the forecast held. So I prefer to keep my what I call boat information front burner. Boat information means wind speed, wind direction. It means what the barometer's doing. It means what the clouds are telling you. If I'm seeing a mackerel sky forming and I'm seeing indications of a fast switching wind, usually veering, and I'm seeing the southeasterly veering to the southwest, and I'm expecting a cold front, and a cold front is if it's in the forecast, fine. If not, I'm wondering why I'm seeing signs of that occurring. So morph what you're actually seeing wind-wise, barometric pressure rise. Good example is barometer drops 2 millibars an hour, you've got some problems coming down the hill and they're close to you.
So using traditional, like a barometer, like observation, like sea state, water temperature, all these observations from your vessel can be helpful.
Absolutely. One of the trickiest ones of all is when you run into a big swell and no wind. First question that comes to your mind is what's creating that wave train? Where's it coming from? And you should be able to locate in your forecast the genesis of that particular sea state. And I'll go looking for that fast because you have a large wave train to start with. That means the next weather system could easily impose some serious concerns with adding wind to that equation, or a lot of wind to that equation.
Yeah, my question is this a residue or is this what's coming?
Exactly. Residue that is not going to affect you at all, or is it, what has you in the crosshairs?
Tropical weather. Let's talk about that a little bit.
Probably the main concern I have about tropical weather most recently is the underplay that we're giving to tropical storms. We're all worried about hurricanes, especially the higher 3, 4, 5 category hurricanes. But a tropical storm can bring you quite a bit of woe with winds between 35 and 65 knots, seas that can be quite significant, and the concern that it's coming out of the south, and many people try to scoot across the track that storm is riding on with the idea that they're going to get by before the tropical storms arise. The typical tropical storm moves pretty quickly. It's not unusual to see 15 to 20 knot speed over the ground, and most of us are doing 6, 7 knots. We're not able to weather route away from that tropical weather. Tropical storms also change as they lose their warm core and advect a cold core, add cold front and warm front, and then spread out. Sandy was an example of a tropical storm that changed into an extratropical storm just as it made landfall, spread out, and was a really significant weather system. So avoiding tropical storms by prudent judgments about go, no-go decision making makes a world of sense.